All right, we're going to look at another example of solving an equation or a system with three variables, three equations and three variables. All right, so first let's organize our work. I'm going to label my equations. This is equation A, equation B, and equation C. All right, and remember, our goal here is to use elimination and to try to reduce the number of variables that we're dealing with. Ultimately, we want to get an equation that has just one variable so that we can solve it. All right, and so let's start to eliminate variables. And you can choose any variable that you want. I think I'm going to eliminate x. I think that would be an easy one to do. So I'm going to use equations A and B. All right, so let me rewrite this. So equation A is this, 3x plus 5y plus z equals -1. And then equation B is this, x minus y plus 3z equals -3. All right, and so to do an elimination here, if I want to eliminate x, and again, you don't have to do x, but I think it's an easy one to do here. Let's see, this is +3 already, so I'm going to need to multiply equation B by -3. So I'm going to multiply equation B by -3, and let's see what we get. Okay, so equation A is going to be the same, 3x plus 5y plus z equals -1. And then equation B is going to be -3x plus 3y minus 9z is equal to +9. Okay, and then if I add these together, let's see what we get. This is, the x's are going to be eliminated, and then the y's, I'm going to have 8y plus, oops, I'm sorry. It's going to be, let me grab my pen, minus 8z is equal to +8. All right, and kind of an interesting thing happened here. All right, we're going to use this for equation D, but if you notice here, we have an interesting thing with these coefficients. We have them all, they're all 8. We have 8y, -8z, and +8. Right? So here's a little trick that you can use. If your coefficients have a common factor, you can divide by that common factor. Right? Here's what I mean. Right? We could divide both sides by 8. And what would we get? We would get 1y minus z is equal to 1. And then we can call this equation D. Right? And it makes sense because these two equations here are equivalent. Right? If you can multiply equations, you can also divide equations. Just the only thing you've got to be careful of is make sure you divide both sides, right, by the same number. In this case, I need to divide all three terms by that 8. Right? So here's equation D. And it worked. Right? We got rid of our x variable. Right? But we're not done yet. We still have quite a bit to do. So, and actually, I'm going to let you do a little bit here. I want you to pick two other equations here and eliminate x again. Right? Remember, we're trying to create another equation that, just like equation D, is missing the x variable. Right? Only has two variables in it. Right? So go ahead and do that. Try to use two different equations and eliminate the x. Go ahead and pause and do that. All right, let's check and see and compare what you did with what I'm going to do. I think I'm going to use equations B and C. So equation B, let me rewrite that, was this. X minus y plus 3z is equal to -3. And equation C is this. -2x plus 3y minus 4z is equal to -2. Right, and the key thing to remember is that if we eliminated x the first time in this problem, in this side, let's do that again. Right, we need to eliminate the same variable over here. Right, so here I've got a -2 coefficient for x. Here I can multiply equation B by +2. All right, so I'm going to multiply equation B by 2 on both sides. And let's see what we get. That's going to give me 2x minus 2y plus 6z is equal to -6, and equation C is going to stay the same. All right, if I add those together, again the x's are eliminated, and what do I have left? I have y plus 2z is equal to negative 8. And this right here would be equation E. Right? So again, why did that help us? Well, that helped us because now I have two equations that only have two variables in them. Right? We eliminated x in both of them, so we have two equations that only have two variables. Right? And that's super easy to deal with. Right? Let's go over here. I'm going to have you pause again and do some work on your own. I want you now to take equation D, which is this, y minus z is equal to 1, and equation E, which is this, y plus 2z equals negative 8. And do an elimination again so that you only have one variable. Right? Go ahead and do that. Pause and do that. Alright, so this one should have been pretty easy. Let's see if you got it right. I'm going to go ahead and multiply the top equation, equation D, by negative 1. So negative 1 times this one. And what am I going to get? I'm going to have negative y plus z is equal to negative 1. And then equation E is going to stay the same. Y plus 2z. Let me write that better. Y plus 2z equals negative 8. And let's see what we get. This time my y's are going to be eliminated, and I'm going to be left with 3z is equal to negative 9. So then if I divide both sides by 3, I have z is equal to negative 3. Right? And there I've solved for my first variable. I have z equals negative 3, and now the hard part's over. Now we just need to use substitution and find out what x and y are. Right? So think about that. Where should I do a substitution with this z? Right? Would I put it in A, B, C, D, or E? Right? The answer is I either want to do it in D or E. Right? Why is that? Because those two equations only have two variables in them. Right? I wouldn't want to put it into A, B, or C yet. Right? Go ahead and do that. Right? See if you can finish this problem, actually. Pause and see if you can finish. Alright, I'm going to go ahead and finish, and it doesn't matter at this point if I use D or E. I'm just going to use E. It doesn't really matter. So E says y plus 2z equals negative 8. And I'm going to replace z with negative 3. So y plus 2 times negative 3 equals negative 8. So this is y minus 6 equals negative 8. And then if I add 6 to both sides, we get y is equal to negative 2. Right there, I've got my second variable. We've got z, we got y. Now all I need is x. And then at this point, where should I do my substitution? Right? I've got two of the variables. Right? I need to plug it into one of the original ones to find the x. Right? So let's say I use, how about equation B? Equation B was this, x minus y plus 3z is equal to negative 3. Let's go ahead and plug our numbers in. So x minus my y value, which was negative 2, plus 3 times my z value, which is negative 3, equals negative 3. Almost done. We have x plus 2 minus 9 equals negative 3. This is the same thing as saying x minus 7 equals negative 3. And then to finish, I'm going to add 7 to both sides, and we get x is equal to 4. Okay, so after all of that hard work, we have our answer, which is the ordered triple x4, which is 4, my y value is negative 2, and the z value is negative 3. Okay, this is my x, my y, and my z that satisfy the system.